Hi guys, this is the video for Unit 8, Part 1, Day 5, the unit circle. So the unit circle is called a unit circle because the radius of this circle is 1 unit. So what we are doing today is we are filling in the unit circle with all of the angle measurements and all of the coordinates. Now once again, since the unit circle has a radius of 1 unit, that means this distance across is 1 unit. This distance across is 1, this distance across is 1, and this distance across is 1, all the way around the circle since the radius is 1. So I can go ahead and label this coordinate as 1, 0. This coordinate at the top is 0, 1. Coordinate over here is -1, 0. And the one on the bottom is 0, -1. Now for the angle measurements, if I were to go halfway around the circle, that is 180 degrees. A full rotation is 360 degrees. So I have those two angle measurements. If I were to cut 180 degrees in half, that gives me this is 90 degrees. So each quadrant is 90 degrees. So down here is going to be 270 degrees. Now if I were to cut 90 degrees in half, that would give me this angle over here. So half of 90 is 45 degrees. So each angle measurement in the middle of the quadrant is an increment of 45 degrees. So 45, 90, add another 45, that gives me this one, which is 135. 45 gives me 180. Another increment of 45 is 225. Another increment of 45 is the 270, plus another 45 is 315 degrees, plus another 45 gives us a 360 degrees. All the other angle measurements are increments of 30 degrees, so this is 30, 60, 90 is already taken, or already done, 120, 150, just adding increments of 30 degrees, 180, 210 degrees, 240 degrees, 270, 300, 330, and then finally 360 degrees. Okay, so filling in the angle measurements in radians, well, we already know that 180 degrees is equivalent to pi radians. So 360 degrees is equivalent to 2 pi radians. Now if I were to cut 180 degrees in half, that gives me the 90 degrees. So if I were to cut pi in half, that's going to be pi over 2, or half of pi. So every increment of 90 degrees is pi over 2 radians. So this is 1 pi over 2. 2 pi over 2 gives us pi when we reduce it. 3 pi over 2. And then 4 pi over 2 gives us 2 pi when we reduce that. Now if I were to cut 90 degrees in half, that's 45 degrees. So if I were to cut pi over 2 in half, that's going to give me pi over 4. So every increment of 45 degrees is equivalent to pi over 4. So I have 1 pi over 4, 2 pi over 4 reduces to pi over 2, 3 pi over 4, 4 pi over 4 reduces to pi, 5 pi over 4, 6 pi over 4 reduces to 3 pi over 2, 7 pi over 4, and then 8 pi over 4 reduces to 2 pi. For the 30 degrees is equivalent to pi over 6 radians. You can convert it if you want to, but it's pi over 6. So every increment of 30 degrees is pi over 6. So I can count around the unit circle. So this is 1 pi over 6, 2 pi over 6, which I can reduce to pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6, which I can reduce to 2 pi over 3. 5 pi over 6, and then 6 pi over 6 is pi, 7 pi over 6, 8 pi over 6, which I can reduce to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 I can reduce to 5 pi over 3. And then finally 11 pi over 6. And then 12 pi over 6 gives us that 2 pi. So that covers all of the angle measurements in degrees and radians. And now we need to figure out the ordered pairs. So your ordered pairs come from the special right triangles. So the first triangle I'm going to look at is this one over here. So we know that this is 30 degrees, so this is going to be our 30, 60, 90 triangle, which is this triangle over here. Now the radius for our circle is 1 unit. Right now this length is 2 and it needs to be 1. So what I'm going to do is I'm going to divide everything by 2. So that gives me 1. So my horizontal distance is 3 pi over 2. Vertical distance is 1/2. So if I go back to my unit circle, horizontal distance is 3 pi over 2. Vertical distance is 1/2. Which means my ordered pair for this is, why do I keep saying 3 pi over 2? It's root 3 over 2, and then 1/2. Sorry about that. For the 45 degrees, I'm looking at this triangle. So this right here is 45 degrees. So I'm going to go to my 45, 45, 90 triangle, which is this one over here. Now once again, our radius has to be 1, so that means the hypotenuse should be 1, so I'm going to divide by the square root of 2. So this equals 1. Whenever we have a radical in the denominator, we have to change it, so that's root 2 over 2. And then this one right here is also root 2 over 2. So that means my horizontal distance is root 2 over 2. Vertical distance is also root 2 over 2. So horizontal distance, root 2 over 2, vertical distance, root 2 over 2, which makes my ordered pair root 2 over 2, comma, root 2 over 2. For the 60 degrees, looking at this triangle over here, this angle measurement is 60 degrees. So I'm looking at the 30, 60, 90 triangle again, but I rotated it. So I have that angle measurement being the 60 degrees. Again, your hypotenuse has to be 1 because it is a unit circle. So I'm going to divide everything by 2. So horizontal distance is 1/2. Vertical distance is root 3 over 2. So horizontal distance is 1/2. Vertical distance is root 3 over 2. Now to get the other quadrants, what you're doing is you are going to reflect these ordered pairs into your other quadrants. So your quadrants, if you recall, your first quadrant, your x is positive, y is also positive. Your second quadrant, x is negative, y is positive. Third quadrant, they're both negative. And then fourth quadrant, x is positive and y is negative. So I'm going to keep that in mind as I reflect. So I'm going to start with my first point for the 30 degrees. I'm going to go straight across, and it's going to give me this ordered pair. The only difference is that now my x is negative. So that's going to be negative root 3 over 2, and then positive 1/2. For my 45 degrees, going straight across, and it's going to give me the same ordered pair except my x is negative. So root 2 over 2, root 2 over 2, x is negative. Straight across, same ordered pair, 1/2, root 3 over 2, except x is negative. And you can do that to fill in all of the coordinates. So this one's going to go straight down. They're both negative. So that's negative root 3 over 2 and negative 1/2. Straight down, both negative. So that's root 2 over 2, root 2 over 2, both negative. Straight down, both negative. So that's negative 1/2 and negative root 3 over 2. Straight across, x is positive, y is negative, so that's positive root 3 over 2, negative 1/2. Straight across, x is positive, y is negative, so that's root 2 over 2. It's a weird looking 2. Root 2 over 2 and negative root 2 over 2. Straight across, x is negative, x is positive, y is negative. So positive 1/2, negative root 3 over 2. And that gives you all of the angle measurements, all of the ordered pairs of the unit circle. All right, so what is the unit circle used for? The unit circle will allow us to find any trig value of the angle. So for instance, sine of 30 degrees, sine of 225 degrees, tangent of 150 degrees, all of that good stuff. So going to the actual first example, we are just focusing on sine and cosine. So since we're looking at a unit circle where the radius is 1, what you need to remember is that cosine corresponds to the x-coordinate, sine corresponds to the y-coordinate. So for A, B, and C, all of these points are located on the unit circle. But if you look at these ordered pairs, they don't look like any of the ordered pairs on our unit circle, but they still are on the unit circle. They're just at angle measurements that we have not specified. But what we're looking for is we're looking for cosine of theta and sine of theta. We don't actually care what the angle measurement is. We're just trying to figure out what cosine of theta and sine of theta are. Cosine is your x-coordinate, so negative 5 over 6. Sine is your y-coordinate, so root 11 over 6. And that is your answer. For letter B, cosine is your x, and sine is your y. Very, very simple, since I am giving you the actual points. For letter C, cosine is your x, and sine, 4/3. That should be negative 4/5. And sine is your y, negative 3/5. For D and E, I did not specify the ordered pairs, but I did give you an actual angle measurement, and this angle measurement is on the unit circle. So I'm going to go back to my unit circle. I am looking at 45 degrees, and there is the ordered pair for 45 degrees. So I'm going to go ahead and list that. So at 45 degrees, the ordered pair was root 2 over 2, comma, root 2 over 2. So that means cosine is your x, which is root 2 over 2, and sine is your y, which is root 2 over 2. For letter E, I'm looking at the angle measurement of 4 pi over 3. So going back to the unit circle, 4 pi over 3 is right here. So your ordered pair for that is negative 1/2 and negative root 3 over 2. So I'm going to write that down. Negative 1/2 and negative root 3 over 2. So that means cosine is negative 1/2 and sine is negative root 3 over 2. You just got to remember that cosine is your x and sine is your y. It goes in alphabetical order, by the way. So for instance, xy is in alphabetical order, cs is in alphabetical order, and there you go. Cosine is your x, sine is your y. For this one, we're just finding one of them, not both. So sine of 135 degrees, I'm going to look for 135 degrees on my unit circle. There it is. Sine is the y-coordinate. So your y-coordinate is root 2 over 2. So that means your answer for this is root 2 over 2. Cosine of 11 pi over 6. So I'm looking for 11 pi over 6 on the unit circle. There it is. Cosine is my x-coordinate, so that's going to be root 3 over 2. 690 degrees. So if I look all around my unit circle, I do not see an angle measurement that says 690 degrees. But if you recall, we can use coterminal angles, or we can find coterminal angles. So 690 degrees, I want to subtract a full rotation. So I'm going to subtract 360 degrees. And what I'm really going to look for is cosine of 330 degrees, which is on the unit circle. So there's 330 degrees. Cosine is your x-coordinates, so that's going to be root 3 over 2. So if I give you an angle measurement that you cannot find on the unit circle, look for coterminal angles. So either add a full rotation or subtract a full rotation. Same thing for letter D. Negative 3 pi over 4 is not on the unit circle. So what I can do is I can find a positive coterminal angle. So negative 3 pi over 4. I'm going to go ahead and add a full rotation. I'm going to add 2 pi. So negative 3/4 plus 2 gives me positive 5 pi over 4. So now I can look for sine of 5 pi over 4. 5 pi over 4 is right here on the unit circle. Sine is my y-coordinate, so it's negative root 2 over 2. Alright, and that wraps up our day 5, the unit circle.